Why does your character feel so lifeless even after adding movement, jump and dash? Take a look at this. It's not your code, it's your animation. Right now our player look like this, just sliding around. But we are going to fix that and turn it into this. So, in this video, I will show you how to animate your 2D character in Unity step by step using a simple and beginner friendly approach. By the end of this video, your player will have proper idle, jump, run, fall and dash animations. Now, in Unity, there are two types of animation: sprite based animation and bone based animation. Sprite based animation use multiple images, while bone based animation use rigging. For our 2D game, sprite based animation is simple and perfect, so that's why we will use. And for this tutorial, I am using free Sunnyline assets from Unity Asset Store. Before we start, let's quickly understand how animation works in Unity. We have three main parts: animator component, animator controller, and animation clips. The animator is attached to the player. The controller handles the logic, and the clips are the actual animations like idle or run. Let's open the animation and animator windows from the window menu. Select the player and add an animator component. Then create a new animator controller and assign it to the player. Now go to animation window and create a new clip called player idle. Save it in our animations folder. Then go to the idle folder and drag all the sprites into the timeline. Now if you play the animation, you will notice the animation is too fast. That's because the sample rate is too high. Samples control how fast the animation plays. So if we reduce this value, the animation becomes slower. Let's set it to around 12. Now the animation looks much more natural. And that's it. We have successfully added our first animation. Now let's add a run animation to our player. Create a new animation clip called player run and add the running sprites to it. If you play this, it's too fast again. So just like before, reduce the sample rate to around 13. Now it feels much more natural. And that's it. We have created our run animation. Now let's connect this animation with our player movement. So basically, when the player moves, we want the run animation to play. And when the player stops, it should go back to idle. To do that, go to animator window. Each box you see here is called state. Every state represents an animation. You will notice that our idle animation is connected to entry, which means it's the default animation that plays when the game starts. Now let's connect idle to run. Right click on the idle state, select make transition and then click on the run state. Next, select the transition. Now we need a condition to tell Unity when to switch animations. So for that, we will create parameter. Go to parameters tab, click the plus icon and create a float parameter called speed. This parameter will control whether the player is moving or not. Now come back to the transition and add a condition. Set it to speed greater than 0.01. So even a very small movement will trigger the run animation. Now let's make the transition field responsive. Disable has exit time. This makes sure the animation switch immediately instead of waiting. And set transition duration to 0. So there is no delay between idle and run. Now we also need to go back from run to idle. So create another transition from run to idle. And this time, set the condition speed less than 0.01. Basically, when the players stop moving, we return to idle. So what's happening here is, we are using the speed parameter as a simple way to tell Unity whether the player is moving or not. Now let's control this parameter from our script. To do that, we need a reference to the animator. So we create public animator variable and assign it from the inspector. Now inside update, after getting our input, write animator.setFloat speed, mathap.apps movementinput.x. Here is what happening. Movementinput.x give us horizontal movement. If we move right, it's 1. If we move left, it's -1. But our animation doesn't care about direction. It only cares if the player is moving or not. So we use mathap.apps. This converts the negative value into positive. So both 1 and -1 become 1. As long as the player is moving, speed will be greater than 0 and the run animation will play. And when player stops, it becomes 0. So it goes back to idle. Now let's test it. As you can see, when the player moves, the run animation plays. And when we stop, it smoothly goes back to idle. And that's it. We have successfully connected idle and run animations to our player movement. Now let's add a jump animation to our player. But this time, instead of just playing one animation, we are going to use slightly smarter system. We will play the jump animation while the player is going up and switch to fall animation when the player is starting coming down. This makes the movement feel much more natural. First, let's create our animations. Create a new animation clip called player jump and add our jump sprite. Make sure to disable loop time because jump should only play once. Now create another animation called player fall. Add the falling sprite and again disable loop time. Now let's set this up in Animator. We want the player to jump from anywhere, whether it's idle, running or even mid-state. So for that, we will use any state. Create a transition from any state to player jump. Now we need a trigger to start jump. So go to parameters, create a trigger called jump and add it as a condition. Now let's make this transition instant. For that, disable hash exit time and set transition duration to 0. Now we need to detect when the player starts falling. So for that, we will use the player's vertical velocity. Create a float parameter called vertical velocity. This value comes from rigid body. When the player is going up, the value is positive, and when the player starting falling, it becomes negative. Now we create a transition from jump to fall and set the condition vertical velocity less than 0. So the moment the player start coming down, we switch to fall animation. Now we need to handle landing. For that, we will use a boolean parameter called IsGrounded. This simply tells us if the player is touching the ground or not. Now create a transition from fall to run and set the condition IsGrounded is true, speed greater than 0.01. And another transition from fall to idle and set conditions IsGrounded is true and speed less than 0.01. And for both transition, disable hash exit time and set duration to 0. So when the player lands, we immediately decide whether go to run or idle based on our movement. Now let's connect this parameter in our script. We will update vertical velocity and IsGrounded inside update. Animator.setFloat vertical velocity rigidbody.linear velocity y and animator.setBool IsGrounded, our boolean variable is grounded. We update this every frame so the animator always know whether the player is going up, falling or on the ground. Now for the jump trigger, we only want to trigger the animation when the player actually jumps. So go to our jump function and write animator.setTrigger jump. So whenever the player presses jump, this trigger tells the animator to start the jump animation. Now let's test it. As you can see, jump plays while going up, fall plays while coming down, and when we land, it currently switches back to idle or run. And that's it. We have successfully implemented jump and fall animations with proper logic. Now let's add a dash animation. As you can see, we don't have dedicated dash animation in this asset, so we will just use a single sprite from run animation sprites. That's totally fine for learning and prototype. Now create a new animation clip called player dash. Add the sprite and make sure to disable loop time. Because dash is quick action, we don't want to keep looping. Now go to Animator. Since we want dash from anywhere, like idle, run or even in air, we will use any state. Create a transition from any state to player dash. Now create a bool parameter called isDashing and set the condition isDashing is true. Now let's configure the transition. Disable hash exit time, set transition duration to 0 and disable can transition to self. So whenever isDashing become true, the dash animation play instantly. Now we need to define what happens after the dash ends, and we actually have 3 different cases. First case, if the player is still in the air after the dash, we should go into the fall animation. So create a transition from dash to fall and set conditions. Is dashing false? Is grounded is false. So this means the dash has finished and the player is not on the ground. So we switch to falling. Second case. If the player is on the ground and still moving, we should go into run's animation. Create a transition from dash to run and set conditions. Is dashing is false? Is grounded is true? And speed is greater than 0.01. So when the dash ends and the player is moving on the ground, we immediately continue running. And finally, if the player is on the ground but not moving, we go back to idle. So create a transition from dash to idle and set conditions. Is dashing is false? Is grounded is true? And speed is less than 0.01. So if there is no movement after the dash, we simply return to idle. And for all these transitions, disable has exit time and set transition duration to 0. This keeps everything instant and responsive. Now, let's connect this with our code. Inside the dash coroutine, write animator.setBool is dashing true. We set is dashing to true when the dash starts, and when the dash ends, we set it back to false. And write animator.setBool is dashing is false. So here is how the whole system works. While is dashing is true, the dash animation keeps playing. And when the moment it becomes false, the animator checks all these conditions we created and decide whether go to fall, run or idle. And that's what makes the system feel dynamic and responsive. Now let's test it. As you can see, dash works in the air, it transitions correctly to fall, and on the ground it goes to run or idle depending on the moment. And that's it. We have successfully implemented dash animation with proper logic for all scenarios. Now our player finally feels alive and much more responsive. In this video, we added idle, run, jump, fall and dash animation using Unity's Animator. Now your player doesn't just move, it actually feels alive. Try this in your game and let me know how it feels. If this helped you, consider subscribing. It really helps the channel. And thanks for watching, and I will see you in the next video.